All right, thank you for joining us today. And in this video, what we are going to look at is we are going to look at 2020, 2021, and then we will look at 2021, 2022 objectives questions. So in 2020, 2021, like this one, the questions were 30 objectives and then 4 section B questions, right? That you need to solve everything in the objectives and then you choose 2 questions from the section B. But we are not going to go through the section B. So we have the solution in MERBS series. You can just go through, but I'm not sure if there will be section B this time because mostly I think from 2022, 2023, the question has been objectives, 60 objectives. I don't know whether they are going to change the trend, but I'm sure it's going to be 60 objectives again, right? So we are just going to go through the 30 objectives in 2020, 2021, and then we'll go to another 30 objectives in 2021, 2022, so that it will be 60 objectives. Make sure you go through all the questions provided in the MEP series question, not only to memorize the results. Like for example, I know that the answer is C, but also know the procedure, how we show you how we got the C. So that when you go and let's say instead of this one is let's say P Q prime and they've changed it and let's say they've done like say Q prime belongs to P, you'll be able to also do it, right? You'll be able to know, okay, this is how the solution is. So let me turn it around and see how I can also go through, right? So the idea is whilst you are preparing for the exam, right? As I said, just get some formulas, right? Because Math 101, you need formulas, right? As I said, Math 102, we are going to compare the formulas with the book that you are going to sell next semester. So that one is going to help you to, get the formulas right beside you with the past question or the MEP series, right? So that is what you are going to do. So these exams, stay here with me and make sure that you understand all the procedures, how to tackle each question, and then I bet you'll be okay with the exams, right? So now let's start. Let's just jump right in and see what we can do with this question. So this question is we have set P and then we have set Q, which is then we have the universal set here, and the question is saying that P is in, let's say, Q prime. So what we are going to do is for us to solve something like this, for me, I can just know the answer here right away. But let me show you how I will know the answer right away. I can just assign values to P, right? So P is that, right? And then what I can do is I can assign value to, let's say, Q. Let me say 1, 3, let me say 4, 5, right? And let me say this is my universal set, which is 1, 2, 3, 4, 5, 6, right? So we know that P belongs to Q prime. So the idea is that the way we are doing that, we need to make sure that all the values in here belongs to Q prime, right? So it means that you see the way I've done the thing, I have 1 here, I have 3 here. This is impossible. Why? Because when I find Q prime, there is no way P is going to belong to. So let me show you what will be Q prime or Q complement. Q complement will be values that are in this, but they are not in the values that are in this, but they are not in this, right? Values that are in the what? The universal set, but they are not in Q. So that is the idea. But the idea is that since this guy belongs to this guy here, then it means that in this set, I should have 1, 2, 3, and any other element, let's say 6. So it means that in this set here, for me to get this element here without it being here, then I need to change my Q. So my Q shouldn't involve something that it is in what? P, right? So my Q can be something like 4 and 5. Good. So this one, for you to do it, you can decide to write P first, write Q prime first before you write your Q, right? So if I write P to be this, then since I know that P is in Q prime, then I need to write Q prime first so that I'll have all the elements in P in Q prime, then I add different element to it, or they can be the same. So that now when I finish, this Q prime will help me to get Q. So now let's find for Q. Or let me assume that, let me clean this and let's find for Q. So Q are all elements in this that are not in Q prime. So we can see 1 is here, 1 is here, 2 is here, 2 is here. We can see that 3 is here, 3 is here. You can see that 6 is here. You can see that 6 is also here. So the only elements that are not in Q prime are 4 and what, 5. I can even add 7 to it, and I can have this one to be 4, 5, and 7, right? So this is the idea, right? With how to get to the set so that we can analyze this. Now, can we see that P is in Q? No, there is no way. There is no, P cannot belong to Q. Can we find Q intercept P intercept Q? Yes, of course. P intercept Q. There is no element which is common to them. So definitely Q intercept Q is what? Empty. So it means that the best option that we need to think about here is B. But let's look at other options too. Is P the same as Q? No. Is P the same as Q, and is it empty? No. So the best option for us here is B, option B, right? The best option for us here is option B. So this is how you can analyze the set. So here, pick your P first, and then pick your inverser set, and then make sure that all the elements in P are in Q prime. So when you're able to get the Q prime before, now you can get your Q, and then now you go through the analysis. Right. So that is how we are going to, that's the results that we are going to get for A. Let's move to 2. Now 2, they've given us this set here, and we want to find the true set of the equation if the domain of X is Z plus. So when you see Z plus, right, or Z plus, what we are talking about is we are talking about positive integers, right? So we know integers, right? So integers is like this. Integers is like from minus infinity, minus 2, minus 1, 0, 1, 2 are going, right? But when I see Z plus, then what I mean is 1, 2, 3, 4 are going, right? So this is the positive integer, something like this, positive integer. So what we need to do is we need to solve this one and find out if there is a positive integer, right? So let's take the equation. 3x minus 1 times x plus 1 is equal to 0. So let's solve for x. I can pick this one here and set it to 0. So I'll have x plus 1 is equal to 0, x is equal to minus 1. I can pick 3x minus 1 to be equal to 0, then 3x is equal to 1, x is equal to 1 over 3. Right. So these are the x values that we have here. These are x values, right? So what do we see? We are talking about positive integer here. The x value is a positive integer. So what do we see? You will see that we have the minus 1, we have the 1 over 3, and then we have combined 1 over 3 and minus 1 here. But we can see that minus 1 is not in this set. And we can also see that 1 over 3 too is not in this set. It means that the best option for us to choose here is to choose the empty set, because we don't have positive integer belonging to our x here. Right. So here the best option for us to choose is option C, right? Because minus 1, it is not a positive integer, and 1 over 3 is positive, but 1 over 3 it is not a positive integer. Right. So now let's see for 3. Find the true set of the equation if the domain is Q. So when you see Q, Q is the rational number, right? And what is a rational number? So rational number, right? Rational number is like P over Q, where Q is not 0, right? So any number can be written as a rational number, right? So we can see that this one here, 1 over 3. So 1 over 3 is a rational number. So we can see that, okay, B is here. But the question is 1, -1 to a rational number? Yes, of course. -1 is a rational number because I can write -1 as -1 divided by 1, which means that this is my P and this is my Q. So here, the option for us to is option D. Is that right? So this is how you can analyze the functions. So you need to know that this is a rational number, this is positive integer, right? So know them. So this is for question 2 and question 3. Let's look at question 4. Let's look at question 4. So question 4, we want to find D for which the expression this is a perfect square. You know, one thing about math sometimes is you need to practice, 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 because some questions, if you have not seen it before, it's very difficult to know the right approach to pass through. Do you get it? It's very difficult to know the right approach to pass through. So it's always the best for you to what? Practice. So with this one, since it's a perfect square, the best way for us to go is to use the discriminant formula, right? So when I say discriminant, this is what I mean. We need to use b squared minus 4ac is equal to 0. So this is coming from the quadratic formula, the one under the root, right? So that is the discriminant. So now, when we look at 2d plus 3x squared minus 6x plus 4 minus d is equal to 0, right? Then what will be our, let me see, what will be our a? Our a, remember, this is like in the form of the quadratic function, right? Plus c is equal to 0. So our a here will be the coefficient of x squared, our b will be minus 6, and our c will be the constant term here. So let's try and plug them in. So we know that a is equal to 2d plus 3. We know that b is minus 6, and we know that c is equal to 4 minus d. So you plug it inside the discriminant rule here. So we are going to have minus 6 all squared minus 4 times a, which is 2d plus 3, and then c is 4 minus d, and it is equal to 0. So now what we are going to do is we are going to simplify this and solve for d. So let's do that. Minus 36 squared is, sorry, minus 6 squared is 36. All right. And then this is going to give us minus 4. So I will simplify the one in the bracket here. 2d times this is going to give us 8d. This time this is going to give us minus 2d squared. And then this time this will be 12. 12. And then this time this is going to give us minus 3d, which is equal to 0. That's a 6 minus 4. Let's simplify the one in the bracket. This and that and that. So this will be minus 2d squared. So this combined with this is going to give us 5d, and then plus the 12 is going to be 0. Right. So that's what you're going to get. And then let's multiply through by 4. We are going to have 36. Then minus will be positive. 4 and 2 will be 8. So plus 8d squared. Then minus 4 times 5 is going to give us minus 20d. And then minus 4 times 12 is going to give us minus, I think, 48, and it's equal to 0. So let's make sure that this is in the form of quadratic, right? So 8d squared, and then minus 20d. Then this and that is going to give us minus 12 is equal to 0. So now we have another quadratic function, right? But I can divide through by, let's say, 4, so that the equation will come down. So when I divide through by 4, right, the equation is going to be like 2d squared minus 5d minus 3. So that what I can do is, now the function is in the form of its simplest form, then I can just do it, right? So what can I do here? Here I can use a quadratic function, right? Or the quadratic formula to solve this. Or you can, if I can see the factorization too, I can use the factorization to do that, right? So let me use the factorization aspect. 2 times 3 is 6. So we need to look for factors of minus 6. So plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. These are the factors of minus 6, right? So we need to pick two of them, either 1 and 6 or 2 and 3, so that we can get the 5 here. So let's see. I can pick I can pick 1 and 6, which is going to give us, like, if I pick something like minus 6 and 1, yeah, it's going to work out. But I can also pick 2 and 3, which is also going to work out. I think this one is, yes. So I'm going to pick 2 and 3, but minus 2 and minus 3, so that minus 2 times minus 3 is going to give us something like, let me see, no, minus 2 and minus 3 is not going to work, because when you multiply 2 and 3, you should get minus 6. So when I pick 2 and 3 and multiply, I'll get 6. But when I pick any of them to be minus and positive, it's not going to work. So the best option is 1 and 6. So let me pick 1 and 6. So this is going to be 2d squared, right? Then I can write this one as, let's say, minus 6d, because this is minus. And then the other one will be just plus d minus 3 is equal to 0. The idea is that when I pick minus 6 and 1, then minus 6 plus 1 will give us minus 5. And then minus 6 times 1 will give us the minus 6 here. But when you pick minus 2 minus 3, minus 2 minus 3 will give us minus 5. But when you multiply this, you are going to get positive, not negative. Right. So now what can I do with this first term here? I can factor 2d out. So it will be left with d minus 3. Then plus this one, I can factor 1 out. So I can have 1d minus 3 is equal to 0. So what are we going to get? D minus 3 and then 2d plus 1 is equal to 0. So I combine, since this is common, I factor it out. So when I factor it out, it will be left with 2d plus 1. So now you can find for d. So d minus 3 is equal to 0. So d should be equal to positive 3. And then 2d plus 1 is equal to 0. 2d is equal to minus 1. This implies that d is equal to minus 1 over 2. So let's go and check if we have something like 3 and minus 1 on 2 in the section. So we had d to be equal to 3, d is equal to minus 1 on 2, I think, right? So let's check the options. Minus 1 over 2, and we have the 3 here. So that's the perfect option for us to choose. Good. So you will see that if this question, let's assume that you don't know this formula right here, and I've not seen it before, it's kind of like finding out what to do is going to be very difficult. But I can assure you the way to you can do this one too. The way you can do this one is pick the d and plug them inside the function, right? And see, when you find the quadratic function, you are going to get a perfect square. When you say a perfect square is something like the things that you are giving us 4, 9, 16, 25, 36. These are all perfect square. So it means that when I plug in the d inside this function, right, and I do them, the values of x are going to be perfect square. It's going to be 4, let's say, those kind of things. Like, it should give us a perfect square. So that's another way of doing that. You can pick minus 1, plug it in for d, check if you are going to get perfect square. If that one works for you, then come and pick the other counterpart too. You plug it in and see if you are going to get a perfect square, right? By solving it using the quadratic function. And then, so what I mean is, like, if I don't know this one, then the next best approach for me to do is I'll pick the minus 1, plug it in, right? So let me just do for minus 1. So when I plug in the minus half here, I'm going to have 2 times minus half plus 3 all times x squared minus 6x plus 4 minus 1 over 2 is equal to 0. So half of this is going to give us minus 1. Minus 1 plus 3 is 2. So 2x squared minus 6x. Then half of this is going to be like positive. So this is like 8 over 2. So this is going to give us plus 9 over 2 is equal to 0. I can multiply 2 by 2. So I'm going to have 4x squared minus 12x plus 9 is equal to 0. So let's solve for this, right? Let's solve for this and see if we are going to get a perfect square, right? So let's look at what we can do here, right? Let's see if we are going to get a perfect square from here. All right, so we can use the quadratic function or the quadratic formula, or we can just do the idea of multiplying this by this, which is going to give us something like 9 times this one is going to give us like 36, right? Then look for factors of 36. That will satisfy the idea that when I add them, I'm going to get 12, but when I do the other things, I'm going to get 36. So what value? 6. Let me say two values. That's so factors of 36 is 1, 2, 3 is right. Can I think of 4? Yeah, 4, 2 is going to work. 6 is going to also work. 6, 36. Good. So 6 will work because 6 is like 6 times 6 is 36. Minus 6 is going to give us 12. So 4x squared minus 6x minus 6x plus 9 is equal to 0. Good. So what can I do here? I can factor 2x out. So I'm going to have something like 2x again minus 3, I think. Is that right? Yes. Yeah, that is right. Because 2 times 6 here, 2 here will be 6. Yeah, right. Then what can I also do here? Minus, I can factor 3 out. So this one will be like 2x. Let me say 2x minus 3 should be equal to 0. Is that right? Multiply it and let's see. This and this will be 6. And good. So when I factor 2x minus 3 out and then factor 2x minus 3 out, I'm going to get to be 0. And guess what is happening here? I have 2x minus 3 is equal to 0. So x will be equal to 2 over 3. The same thing there, 2x minus 3 is equal to 0. X is equal to 3 and x is equal to 2 on 3. So you see that these x values are perfect square. Why? Because remember, we talked about perfect square. We said 4, 9, 16, 25. How do we get 4? The 4 here is 2 times 2, right? How do you get 9? 9 is 3 times 9. Sorry, 3 times 3. How do you get 16? 4 times 4. So it means that now this is like a perfect square because this is something like 2 over 3 times 2 over 3. So this is like 2 over 3 squared, which is the same as 2 squared here, right? So that is the idea. So you see that half worked out. So it means that when you finish, you need to plug in 3 to check if it's going to work out. Before now, you can choose the option, let's say option A to be the results. If you don't know that, you need to use the discriminant rule. So that is another smart way that you can use. So with objectives, we have so many ways of solving it, right? But the idea is that you need to solve more questions to find out that, okay, this is the right procedure for me to go through. All right, let's look at question 5, 6, and 7 together, right? So this one is like a question that when you're able to do it, you get a bonus tip, right? You just do one thing and then that's all. So here we want to express this function in this form, right? So for us to do that, we need to use the completing of squares, right? We need to use completing of squares. So what do we want to do? We want to express the function in the form y is equal to m minus n in bracket x plus p squared. That's what we want to do. So what is the function? Y is equal to 5 minus 2x minus 4x squared. So here we need to go through the idea of what? Discriminant rule, right? We need to go through the idea of discriminant, right? So that is the idea that we need to, use. So let's try and then go through using the, did I say discriminant? No, we need to use the idea of, let me say, the completing of squares, right? In my mind, I'm just thinking a lot. So let's look at what we can do here. So y is equal to minus 4x squared minus 2x plus 5. So I just brought this one first and send this one there so that we can have it in the form of ax squared plus bx plus c, right? So what can we do? We need to make sure anytime we want to start something like this, we need to make sure that the coefficient of this is 1, right? The coefficient of x squared is 1. So what I can do is I can factor the minus 4 out. So I'm going to factor minus 4 out. Then when I factor minus 4 out, this minus 4 that I've factored it out, I'll use to divide everything here. So I'll divide this one by minus 4, which is going to be left with x squared. Divide this one by the factor here, which is minus 4, which is going to give us plus 1 over 2x plus this divided by this eventually is going to give us rather minus 5 over 4. So when I'm done with this one, now I can see that now the coefficient of this now is 1. So now I come to the coefficient of x. So using the completing of squares, what we need to do is we need to find half of the coefficient of x. So the coefficient of x is 1 over 2. What is half of 1 over 2? Half of 1 over 2 is actually 1 over 4. So what we are going to do is, now we have this equation here, we want to add 0 to it. So we are going to add plus 1 over 4 squared minus 1 over 4 squared. So we know that plus and minus will actually give us 0. Right? So we are adding 0, but not just a 0, something like this, which is going to give us 0. So we are going to have minus 4 open bracket x squared plus 1 over 2x. Then I'll add what I had there. So let me use red pen to do it. 1 over 4 squared minus 1 over 4 squared, then minus 5 over 4. So now what can we do? We are going to combine this term with blue here, right? So this is going to give us minus 4 open bracket. I can combine the term with the blue, right? And get something like x plus 1 over 4 all squared, right? So I pick what is here, x, without the square. I pick the 1 over 4 here without the square. Then I square them. And when I expand this, I'm going to get what is here, right? So now then the terms left is this. So now I'm going to have minus 1 over 4 squared is 1 over 16 minus 5 over 4. So let's simplify that. We are going to have minus 4, then x plus 1 over 4 all squared. Then when I simplify this, what is minus 1 over 4, 1 over 16 minus this. So this is like, I can write this 1 over 16. So this can be written as, for me to get 16 here, I need to multiply this one by 4 and this one by 4. So I'm going to have, I think 4 times the top will be 20 divided by 16. So it will be minus 1 minus this one. So this is going to give us minus 21 divided by 16. Yes. So my last step is going to be, let me shift this once more. My last step from here is going to be, what I need to do is, I need to multiply through by minus 4 because I'm done with the simplification. So I'm going to have minus 4 x plus 1 over 4 squared. Then when I multiply the 4, this minus will be positive and 4 will cancel here 4. So I'm going to have plus 21 divided by 4. So that's what I'm going to get for my last step. So let me go up here and just clean some of the solution up here and come and put my y there. So y was equal to minus 4 x plus 1 over, I think, 4 squared plus 21 divided by 4. Let me check if it is true. Yeah, minus 4x plus 1 over 4 squared. Good. So now let's write this in this form. So what I can do is I'll bring the 21 over 21 over 4 first by the 4 minus 4x plus 1 over 4 squared. So now let me clean this. So now let's see how these terms are related. So I can see that m is equal to this here. So automatically I know that my m is equal to 21 over 4. I can see that my n is here because this is minus, this is also minus. So my n will be equal to 4. Then what is my p? Oh, good. This is plus. This is also plus. Let me check the form, whether it's supposed to be plus there. Yeah, it is plus there. So let's see. This is going to be p is equal to be 1 over 4. So now let's look for what the question is looking for. The question is we should find m and n. So what did we get for m? M is 21 over 4. Okay, I think they did it in the whole number. So 5 times 4 is 20. 20 plus this will be 21 over 4. So this is the same as that. So m is 21 over 4 and n is 4. So what will be the right choice? The right choice will be this one. So we are going to have this one to be the right choice, right? So n is 4 and m is 21 over 4, which is this one here. Now this question is asking us for p. What did we get for p? P is 1 over 4. So you see, we just did one question and then we are getting a lot of, solution from there. The question is, what is the maximum value of y? What is the maximum value of y? For question 7, what is the maximum value of y? So remember, the maximum value of y is actually the m here, right? The maximum value. This is the maximum value. This is the max value. So we know that m is 5 whole number 1 over 4. So this becomes the max value, which is m. So we have the m right here, right? Then what is the find the value of x for which y is maximized? So actually that one is not p, but what we need to do is, that's what we call the axis of symmetry. So we need to pick what's in the middle here and equate it towards 0. So x plus 1 over 4 is equal to 0, and x should be equal to minus 1 over 4, right? So we need to get the negative of p. So that one is going to give us this O. So fortunate, even they didn't even trick us that they are going to put something like 1 over 4 for us to go and choose. But it was like this. So it's like, that you need to negate the P and then you get the Y value. So you see, we just solve one question and we use it to solve 4. We have used it to get 4 questions done, right? So that's the reason why I'm saying that when you were able to do the completing of squares and you know the terms, you should be able to get these 4 questions right. Okay, so now let's look at question 9. Question 9, we have this equation here. We have alpha, beta, and then these are the new roots, right? And we want to form the equation. So stay here with me, right? It's so nice to know how to solve questions, right? So each question, you will see, we are going to learn how to go through them. And even if you don't know how to go through them, now I'm explaining them so you'll be able to understand the solution provided better, right? So now this is the equation given and we want to find new equation, right? So something like this is like, for us to find new equation, we need to find the new sum root and the new product root, right? So what will be the sum root or sum of roots? Now we know that sum of roots sum of roots, which is let me say sum of root is equal to, this is quadratic, so this is minus b over a, right? That is sum of root. So now let's go to our function, which is given 2x squared minus 7x plus 1 is equal to 0. When I compare this one to the quadratic function, I can see that a is equal to 2, b is equal to minus 7, and c is equal to 1. So it means that the sum of root from this function, I'm going to have something like this. What am I going to get? B is minus 7, so minus 7 divided by a is 2. So I'm going to have 7 over 2. This will be the sum of root. Let's look at product of roots. So product of roots is equal to c over a. This is going to give us, what is c? C is 1 and a is 2, so 1 over 2. So this is the sum of root and product of root of the equation, right? Now the idea is that we need to find the sum of root of the new equation. But don't forget, let me show you something here. The sum of root, remember our root here, which is of the equation here, is alpha and beta, right? So it means that since alpha and beta is the root of this, then it means that this 7 over 2 is equal to alpha plus beta, because we are talking about sum of roots. So we need to sum the root that we have. And this is product of root. So let me use red ink to do this one. So alpha plus beta. And this is the product of root. So this is going to be alpha beta. So that is the idea. So let me write them here. So now we have alpha plus beta to be equal to 7 over 2 and alpha beta to be equal to 1 over 2, right? So I found the sum of root from this equation, but I know that alpha and beta is the root of this. So sum of root, product of root, which is going to give us this. So what we need to do is, now we want to find sum of root of the new equation. Now these are the new roots given to us, right? These are new roots. So we need to find sum of root. We need to add this, right? So what will be the sum of root of the new equation? Let me use red to do that so that we will see that this is a new root. So sum of roots is equal to this. We are going to sum this because this is the new root. So we are going to sum 1 over alpha plus 2 plus 1 over beta plus 2. Is that right? Good. So let's sum this. I'll have 1 over alpha plus 1 over beta. 2 plus 2 is 4. So let's try and find the LCM here so that we can simplify this. So when I find the LCM, this will be alpha, beta. Alpha goes here, it will left to beta, so the top will be beta plus alpha plus 4. This is the same as alpha plus beta divided by alpha beta plus 4. Good. So this is what we are going to get at the end of the day, right? So what can I do now? Now I know alpha plus beta to be 7 over 2. I know alpha beta to be 1 over 2, so I just sub them. So I'm going to have 7 divided by 2, right? This is on the top. Now divided by, so I'll write it like divided by beta alpha, which is 1 over 2. 1 over 2, right? Then I'm putting this one in bracket so that I can add the 4 to it. So what can I do with this? Let me shift this one to this side here so that I can see that this is equal to 7 over 2 times 2 over 1 plus the 4. Now 2 cancel the 2, so I'm going to have 7 plus 4, which is going to give us 11. So the sum of root is 11. Let's go and check if we have 11 there. Good. So this is going to give us C here. Now the next thing that we need to do is we need to find the product of roots, right? So let me clean this since we've used this one already. So product of roots of the new equation is equal to, so what we need to do is now we need to multiply this new root here. So what can we do? We are going to have 1 over alpha plus 2 times 1 over beta plus 2. Right. I hope you are enjoying it. So let's just multiply this times this is going to give us 1 over alpha beta plus this times this is going to give us 2 over alpha plus this times this is going to give us 2 over beta plus 2 times 2 is going to give us 4. So fortunate for us, um, we have alpha and beta right here, so it means that we can plug in the half, but here we need to actually find LCM with these two so that we can combine them together. So this is going to be 1 over alpha beta plus the same alpha beta, so this is going to give us 2 beta plus 2 alpha plus 4, right? So when you find the LCM, alpha will cancel this, so it will be left with beta. So I'll multiply beta by 2. Beta will cancel this, so it will be left with alpha. I'll multiply alpha by this, and then I get it here. So what can I do? Here is 1 over alpha beta plus. Here I can factor 2 out. So I'm going to have 2 out. And then I can swap the alpha beta because this one is going to be like beta plus alpha, which is the same as alpha plus beta. So it will be alpha plus beta divided by alpha beta plus 4. Right. So this is what we've gotten now. Let me shift it here. So let's now try and sub them inside the substitution. So this is going to be 1 divided by what is alpha beta is 1 over 2. So I'm going to have 1 over 2, then plus 2 times what is alpha plus beta, 7 over 2, divided by alpha beta here is also 1 over 2. I hope you find it very hard to see. Let me just shift this one up small so that we can use them, since we are not using this one again, so that we can write it very well. So 1 divided by 1 over 2, or let me use, so this is 1 over 2 plus 2 times the sum of root is 7 over 2 divided by the product root alpha beta is also 1 over 2 plus 4. Right, so you see that this is here, which is equal to this. This is also here, which is equal to this, and this is here, which is also equal to this. So now let's try and simplify. 2 times 7 over 2, this will cancel that, right? So this is going to give us something like this. 1 over 2 will give us 2, right? Good. And this is going to give us 7, so plus 7 divided by 2. So divided by means that this is going to be like times 2 plus 4. How did I see that? Is that right? Yes. If this one cancels this, we are going to have 7 over 2. Sorry, 7 over 1 over 2. And 7 divided by 1 over 2 is the same as 7 times 2. So that's what you're going to get from there. So this will be 2 plus 2. 7 times 2 is 14 plus 4. And this is going to give us 20, right? So the product rule is going to give us 2, 0. So let's see, it is there. What is 2, 0 here? So the last question here is for us to find the new root, right? So what is the new root? Since this is y, we are going to say the new root is y squared minus sum of roots x plus product of root, which is equal to 0. So what is sum of root? Now, since we are talking about new equation, the sum of root is the sum of root from the new equation, right? Or new root, and then the product of root. So we saw that the sum of root was 11 and the product of root is 20, right? So this is going to be y squared minus 11x, because this is the sum, which is 11, plus 20, which is equal to 0. So very simple. This is what you're going to get. So when you look at the options, what will be the option? The option should be, I think, A, right? Yeah, something like that. And then we are done. So the option should be A right there. So that is the idea, right? So you see the way we are dealing with each questions and how we need to approach them. Let's look at question 12. Let's look at question 12. Right. So what is question 12? We have this function here, and then with this and this to be a factor of this. So one thing that you need to know about factors is saying that if this is a factor of this, then when I make x the subject and I plug it inside, I should get 0, right? So it means that if something is a factor of something, then it's a zeros of the function. Like it means that when I plug it inside, I need to get 0, right? So what I'm going to do is I'll pick the first factor, which is x minus 1. Since it's a factor, this is equal to 0, and x should be equal to 1, right? I pick the second one, x plus 2 is equal to 0, and x is equal to minus 2. So what I'm going to do is, when I plug in 1 into this, I should get 0, because um, x minus 1 is a factor and x is equal to 1 is a root of this or a 0 of this. The same thing applies to this. So let's assume that y is f of x. So I'm going to have f of x to be equal to 2x cubed plus px squared minus s plus q, right? Now we are saying that since this is a root of this, then when I find f of 1, I should get 0. So it means that what is f of 1? Let me plug f of 1, let me plug it inside there. So I'm going to have 2 times 1 to the power 3 plus p1 squared minus 1 plus q, and this should give us 0. So this is going to be 2 times 1 plus p times 1 minus 1 plus q is equal to 0. So 2 plus p minus 1 plus q is equal to 0. So what are we going to get at the end of the day? We are going to have 2 minus 1 is like 1 plus p plus q is equal to 0. Let's make p the subject here. P will be equal to minus q minus 1. So this is equation 1. Right. So the next thing that we need to also do is we need to make sure we plug in minus 2 to get another equation, right? And then we solve them simultaneously. So another one that we need to do is f of minus 2 should also give us 0. So what is f of minus 2? Let's plug in minus 2 inside the equation. Minus 2s cubed plus p minus 2 squared minus 2 plus q, right? So this is 0. So what are we going to get? We are going to get something like, this is 2 times minus 8 plus p times 4 plus 2 plus q, right? So this is 0 is equal to minus 16 plus 4p plus 2 plus q, and then 4p plus q minus 16 plus 2 is going to give us minus 40, which is equal to 0. So what can we do? We can make, let's say, we can make q the subject, or let me say p the subject. Let's make q the subject here. So q is going to be 14 minus p, no, 4p, right? Good. So let's call this one to equation 2. So now what we are going to do is we are going to solve equation 1 and equation 2 simultaneously. So since we've made q the subject here, p the subject here, we can say that put equation 2 into what? Equation 1. So what are we going to get from here? We are going to have, if I'm putting this in this, I'm going to have p to be equal to, now q is this. So I'm going to have minus 14 minus 4p, right? Minus 1. So that will be the substitution. So what will be p multiplied through by minus? That will be minus 14 plus 4p minus 1. So what can I do? I can move the 4p to this side. So I get 4 minus 4p. Then minus 14 minus 1 is going to give us minus 15, right? This implies that this is going to give us minus 3p is equal to minus 15p. Let's divide through by minus 3, and we can see that this implies that p is equal to 5, right? So now that we've gotten p to be 5, we can find for what? Q. So we are going to put this p inside this to find for Q. So let's do that. Let me just have a section here. So Q is equal to 14 minus 4 times p. P is 5. So this is 14 minus 20, and this is going to be minus 6. So p is 5 and Q is minus 6. So let's go through the process and then see. So we saw that p was 5 and Q is minus 6. So we just pick one question, right? And then we just solved it. We were able to get the 12. We were able to also get the 13. Now the question is, what is the order factor? Since this is to the power 3, it means that this is going to have 3 factors. So we have one factor here, we have another factor here. So it means that we need to have another factor, right? We need to get another factor. So what can we do? So what we can do here is very simple. I'll just try and show you something which is going to be very simple, right? So for us to go through the whole process again, let me show you the shortcuts, right? So let me just clean my board here, right? So that we can show you the trick that you need to do here. So the trick that we are going to do here is very, very simple here. What I'm going to do is now my y is going to be 2x to the power 3. I know p to be 5, so plus 5 x squared minus x minus 6, which is the Q. So what I'm going to do is I'm just looking at what is here, right? And then try to see if this is going to be true. So what I'm going to do is, remember, if the thing is a factor, then when I plug it in, I should get 0, right? Good. So first, let's look at option A. Option A is already here, which is a factor. Yes, it can be that it is repeated like squared, right? So since this one is here, it is true. It can be that this one too is repeated. We don't know. But what we can do is, let's try and pick D and C, sorry, B and D, and try and make as a subject, plug it in and see what is going to happen. Or another way that we can do is, we can multiply this by this, right? Then we pick any of the factors to multiply them and see if we are going to get what is here. So we have so many ways of doing this. So now let me pick B and just make x plus 3 to be equal to 0, 2x is equal to minus 3, s is equal to minus 3 over 2. So I'm going to plug minus 3 over 2 inside this. And if this is a factor, it should give me 0. So that is the idea. So let's do that and see. Y is equal to 2 times minus 3 over 2 to the power 3 plus 5 minus 3 over 2 squared minus 3 over 2 minus 6. So let's do that. 3 to the power 3 is minus 27 divided by 8, which is true, plus 5 times, this is going to be 9 over 4, plus 3 over 2 minus 6. So let's see if this is 0. 2 cancel this one 4 times, so this will be minus 27 over 4 plus we cannot cancel, so 5 times this is going to give us, I think, 45 divided by 4 plus 3 over 2 minus 6. So since this is having the same LCM, let's try and combine this and this. So 45 minus 27, what are we going to get? So here will be 15, this one will be 8. This is supposed to be 18. Yes. So this is going to be 18 over 4 plus 3 on 2. So let me just do this one to the one here. So I've combined this one and I'm getting this. Let me combine this one too. So 3 over 2 minus 6. 6 is the same as 12 over 2, so that we can have common denominator, right? So when I subtract the top, I'm going to have minus 9 over 2. Is that right? Yes, that is right. So this is what I'm getting. Now you can see that fortunately this guy here, 2 can cancel 18 by 2 and cancel 4 by, cancel 18 by 9 and then 4 by 2 minus 9 over 2. So this is absolutely 0, right? So since this is going to give us 0, it means that the other factor is going to be this. So it means that when I multiply this, this, and this, I'm going to get what is here. That is the idea, right? So if this one was not working, then this will work out. So let's assume that this didn't work, this one too didn't work. Then it means that it can be that one of them is a factor. So for us to find it out, then what we can do is we can multiply this by this, then we pick any of them to multiply and see the one that we are going to have this one. Then we get the result from there. Right. Let's look at question 15. Wow. I love this kind of questions, like use this one to answer question, this to this. It means that if we're able to do it right, you should be able to get all the question right from there. So now let's look at question 15. Right. So we want to find domain of the function. But remember, when we are talking about domain, we are saying that domain is the values, all values of x that what? That satisfy the equation, right? All values of x that satisfy the equation, or let me say that does not make the function undefined, or it makes the function defined. So it means that anytime we are talking about domain, we need to look at, if it is a rational function, we need to look at that down here. So let's assume that y is equal to x minus 1 divided by x plus 1 all squared, right? So this is that. So the domain means that we need to look for, values of x down here that will make sure that the function is not 0. So I pick 1 plus this squared to be equal to 0. So first, what I need to do is, now remember we are saying that for domain, the denominator shouldn't be 0. So I will say that I'm picking this one, but the denominator shouldn't be 0. So what can I do? X plus 1 squared can be written as x plus 1. X plus 1 shouldn't be 0. So I pick x plus 1 shouldn't be 0, right? Mean that x cannot be equal to minus 1. The same thing there, if I pick this one shouldn't be 0, x shouldn't be minus 1. So it means that the domain is all real numbers except x is equal to 1, right? So is it minus 1? Yeah, minus 1. So this is plus or minus 1, which is not true. This is real numbers, which is not true. This one is not true. So the best option for us here is A, right? All real numbers except x is equal to minus 1, or all real numbers, comma, x is not equal to minus 1. So that is what is going to give us. The next question is, we want to find the range. Good. We want to find the range. All right. So if you want to find the range goes with all the y values, right? Domain, as domain is going with x values, we need to go with all x values, right? So that's the idea with range. So let's see. Now with range, now y, let's write our function again. Y is equal to x minus 1 divided by x plus 1 squared. So let's make x the subject, right, from this function, so that we can, or let me see, let's do something here. Let's use the discriminant rule to do this, so that we can have it nice. So let's make sure, since we want to use the discriminant, let's make sure this is in the form of, let's say, let me say quadratic, right? So what can I do now? This is like over 1, so this will multiply this and this will multiply that. So I'm going to have y x plus 1 squared is equal to x minus 1. So y times this can be expanded to be x plus 1, x plus 1, x minus 1. What can I do now? I can expand this to have x squared plus x plus x plus 1 is equal to x minus 1, right? So expand this. Then y will be x squared plus 2x plus 1 is equal to x minus 1. Multiply through by y, and we are going to have x squared yx squared plus 2yx plus y is equal to x minus 1. So let's form the quadratic function here. Yx squared, this is x, move it to this side, plus 2yx minus x plus y, move the 1 to this side, plus 1 is equal to 0. Let's simplify something here. Yx squared plus 2y minus 1, then I factor x out. So x is common, I factor it out. I will have 2y minus 1, then plus y plus 1 is equal to 0. So this is of the form ax squared plus bx plus c is equal to 0, which means that a is equal to y, b is equal to 2y minus 1, and then c is equal to y plus 1. So now we can use the discriminant function to do that. Right. So let's see. Now we can see from the function here that here what we need to do is, let me shift this to this side so that I can use the other side to do the solution. Let me bring this one to also here. So now we are going to use bx squared minus 4ac, right? But the question is, since we are using discriminant, the question is it going to be, let me say, greater than, so discriminant is either this is equal to 0, greater than or equal to 0, or less than or equal to 0. We don't know, right? So for us to know, it means that let's check out if this is minus. If this is minus, then we can say that this should be greater than 0. If it is minus, then this will be less than or equal to 0. If this is positive, this will be greater than or equal to 0. If this is 0 and this is going to be 0, and there is no way this is going to be 0. So the only option is we need to find out if this will be greater than or equal to 0 or less than or equal to 0. So let's find out. We know b to be 2y minus 1 squared. We know a to be y, and we know c to be y plus 1. So minus 4. A is y, and c is y plus 1. So let's try and simplify this. So 2y minus 1, 2y minus 1. Then this will be minus 4. When I multiply, I'm going to have y squared plus 1. Now let me see, let's try and simplify this. So this will be 4y squared minus 2y plus 1. And when I multiply this one, I'll have minus 4y squared minus 4. So let's see something here. I can see that this will cancel this. So I'm going to have something like minus 4y, and then 1, and this is going to give us minus, it's minus 3. Yeah, minus 3. Right. Is that right? Let's check it out. I think I made some mistake here. Okay, good. So I see the mistake here. This one's supposed to be, when I multiply the y through, this one's supposed to be y. So this is going to be 4y. Good. So when I do that, it means that when I cancel that one, I'm going to have 4 minus 4y minus 4y. So I'm going to have minus 8y plus 1. Good. So you will see that, let's look at the range value here. So you will see that except y, when y is 0, that is when this will be positive. So when y is positive value, remember y should be a positive value. If y is positive value, these values here should be, so this one should be greater than or equal to 0. Let me see. Because This one, when y is 0, 1 is true. When y is minus, this one will tend to be positive. So this one should be greater than 0. So I'm going to have something like minus 8y is greater than or equal to minus 1. Divide through by minus 1. Sorry, minus 8. And y will be equal to, since we are dividing through by minus, the sign changes now to 1 over 8. Good. So this will be the results for the function, and we are going to get something here. So what did I do first? Because I wanted to use this discriminant, I just went through this by making sure that this is of the form, in the form of the quadratic, and then I just use the other one. Now somebody will ask, do you have any other way of doing this? Yes, we have a lot of ways of doing this. Another way that I can do this is, here I can make y the subject, right, by interchanging. So here I can interchange x and y and then solve for. So let me do something small for you to see what I was trying to say here. So when I got to this side, when I got to this side, um, when I got to this side, what I can do is, after I've gotten to this side, here I can, if I don't want to use the discriminant rule, what I can do is I want to make x the subject, right? Right, because I need to make x the subject so that the function will be in terms of y only. So if I want to do that, then it means that here we are going to have something like yx squared plus 2yx. Then I move the x here, minus x is equal to minus 1 minus y. Is that right? When I factor x out, I'm going to have y. Yeah, I'm going to have yx plus 2y minus 1 is equal to minus 1 minus y. Right? Or let me say, let me use this one, which is going to be better. I think so. Yeah. So here, what I want to do is, I think the best way to do here is, here when I get this one, I can make this one and have something like x minus 1 divided by y. Good. Then I'll take the square root. So this will be x plus 1 is equal to square root of x minus 1 divided by y. Good. Then my x will be equal to square root of x minus 1 over y minus 1. Good. So this is another way of doing it, right? So you can also use this one to find the domain, right? So the domain means that here I need to pick x minus 1 divided by y, and this should be strictly greater than or equal to 0 because it's under the root. Then you just try to play around this function right here to see if you can get something out of it, right? Good. So now what I can do is I just move to the next question. We want to find the zeros of the function. So zeros of the function means that y was equal to x minus 1 divided by x plus 1 all squared. Zeros of the function means that y should be equal to 0. So what is y? Y is equal to what is here. So x minus 1 over x plus 1 squared should be equal to 0. When I multiply this one by 0, I'll have this x minus 1 to be 0. So x should be equal to 1. So mostly when we are talking about zeros of the function, and that the function is of the form, let me say, rational or a fraction like this, just pick the top and equate it to 0. So you saw that going through everything is just the top, which is equal to 0, and we are getting it to be 1. So x here should be equal to what? 1. Right. Right. Now let's look at question 18. So find the coefficient of x to the power 5 in the expansion x plus y to the power 9, right? So we have xy to the power 9. Now this is of the form a plus b to the power n. So I can know that x is equal to a and y is equal to b and my n is equal to 9, right? So as soon as I do something like this, I'm going to use the shortcut form to be a n minus r and b this. So let's do substitution. N is 9. We don't know r yet. A is x, so we are going to have 9 minus r, and then b is y to the power r. Now I choose r based on, for me to get the 5 here, right? So my r here should be in a way that I'll get the 5 here. So what should be r so that the top here will be 5? Yes, that is right. R should be 4. Good. So it means that this is going to be like, we need to choose R to be 4. So I'm going to have 9 combination 4. And then this one will be, now 9 minus 4 is going to give us the 5. And then we have, this is R, so this will be 4. Which is very nice. So now the question is, what is 9 combination 4? 9 combination 4 is 1, 2, 6. Yes. So you can check it on the calculator, and then this will be that. Good. So the coefficient of this should be actually 126 y to the power 4, but they didn't bring y to the power 4, but still we need to choose the d here. So you see what we did? We need to see that this is equal to this. Pick your A, pick your B, pick your this one, plug it inside this, and it helps you to choose your R. Good. Now let's look at 19. 19, we have this equation here, and with the root this, and we want to find this kind of functions. All right. So what is that? Since this is the root, so we need to find sum of the root here. So what is the sum of root? Sum of roots is equal to, what is the root? The root is this. So sum of root is like, we have so what's the formula for finding sum of root? Minus b divided by a. Now mx squared plus nx plus s is equal to 0. Ax squared plus bx plus c. This implies that a is equal to m, b is equal to n, and c is x. Right? So this is going to give us minus n divided by m. But what is the sum of roots? What is the root given to us? The root given to us is log a log b. So this is the same as log a plus log b. But remember the properties of log. If I have a log of the same base, so this is like base 10, then I can combine this using the property. So this one can be written as log of ab, right? Good. So this is the same as log of ab, and this is the same as minus n divided by m. Good. So we have the c right here, right? And let's do the last one. Last one is the product of roots. We know that it's c over a. Now what is the product of root? This is the root. So we are going to have log a times log b, which will be equal to, what is c over a? C and a. So we have s over m. Then we have s over m. Yes, we have s over m, which is right here. Good. So this is very nice and very simple. Yeah. So the idea is that know the formulas, know how to go through the questions, and know how we are getting the solutions, right? It's not just the matter of, okay, I've seen this question before and this is the solution, this is the solution. Learn how to do the calculation yourself, so that, let's assume that they change it and this is like now log let's say t, and this is, let's say log, let's say c, and they've changed the function, then it means that since you know how to do the process, you'll be able to go through the process and also get your results as required. Right. Let's look at question 21 and question 22. Right. So what are we going to get here? This is equal to this. So this is matrix. Right. So let's do that. So I have 3 and minus 1 multiplying x, y, minus y, minus x, which is equal to 7 and 5. So let's multiply. I pick this one here, make it a row, and use to multiply. So x will multiply this, y will multiply that. So I'm going to have something like 3x minus y. right? So this will multiply this plus this will multiply this. So this times this will be this plus this times this will be just minus y. Then I leave a space and I pick this one to multiply this one too. So this will multiply this plus this will multiply this. So I'm going to have minus 3y. Then x times this will be plus x, which is equal to 7 and 5. So matrix, right? This is the same as this and this is the same as that. So I'm going to have 3x minus y to be equal to 7, equation 1, minus 3y plus x is equal to 5, equation 2. So all we need is to solve equation 1 and equation 2 simultaneously, right? But what I can do here is I can make y the subject and have 3x minus 7. So let me do this one, equation 1, so that I can say plug in equation 1 into equation 2. So I'm going to have minus 3, right? What is y? Y is equal to this, right? So I'm going to have y is 3x minus 7, then plus x is equal to 5. So when I multiply, I'm going to have minus 9x plus 3 times 7 is 21 plus x is equal to 5. Minus 9x plus x is minus 8x, which is equal to 5 minus 21. Then I'm going to have minus 8x, 5, this is supposed to be minus 16. And when I divide 2 by minus 8, x is 2. So what can I do here? I can plug x is equal to minus 2 into this equation 2 here. So y is equal to 3x minus 7 from the equation 2. So y will be equal to 3 times 2 minus 7, 6 minus 7, and y should be minus 1. So x is 2, y is what? Minus 1. So x is 2, which is d here, and then y is minus 1. What did you get for y? Oh, the question did not ask us to find y. Okay, so the question is asking us to find for x minus y. So since we know that x is 2 and y is minus 1, so x minus y will be equal to 2 minus minus 1, and this will be 2 plus 1, which is equal to 3. Okay, so this should be A right here. Good. So this is how you can go through the process for 21 and 22. Let's look at 23. So here we need to know that minus 1, 4, minus 9, and 16. A is minus 1, that is the U1. U2 is 4, and U3 is minus 9. U4 is equal to 16. So I'm not going to do anything calculation here. What I'm going to do is, if I write here U1, it means that this is when n is equal to 1, right? And then n is equal to 2, n is equal to 3, n is equal to 4. So I'm just going to be testing them here to see what is going to produce. So let's start with 1. When I plug in 1 here, what am I going to get? 1 minus 1 will be 0. 2 to the power 0 is 1, which is not true. Is that right? Good. So now let's look at this one too here. When I plug in 1 here, 1 plus 1 will be 2. Minus 1 squared will be 1. 1 squared will be 1. 1 times 1 is 1, which is also not true. So it is out. Let me look at C. When I plug in 1 here, 1 plus 1 is going to be 2. Minus 1 squared is going to be 1. 1 times 2 is not right. So we don't have any option. This one, I don't even need to do the D. Then I'll say that then it will be D. So if it is not D, then it means that there is no option, right? So let's look at it. When I plug in 1 and 1 here, 1 squared is 1. Minus 1 to the power 1 is 1, minus 1. So minus 1 times minus 1 times 1 is minus 1. Let's plug in 2. So minus 1 squared, 2 squared, minus 1 squared is 1, 2 squared is 4. What is 4? What is also there? We can just do like 3. Minus 1 to the power 3, 3 squared. Minus 1 to the power 3 is minus 1 times 3 squared is 9, which is got minus 9. Now let's do 4. Here is 4, here is 4. This will be 1 times 16, and it's also there. So you see that this is a short way of doing that. Do you get it? Good. So for me, if I'm doing it, sometimes you need to use your eyes to see things so that you don't waste your time going through this, testing them, right? So you will see that some of them are not going to work out, and then just throw them away. And then this one is going to give us the D. Let's look at 24, right? Let's look at 24. So arithmetic progression has the first term. So remember the question is saying that first term. So what is first term? First term is A, which is the same as U1. So the first term is 27 base 2. And then the common difference, right? That is the D, is common difference can be like U2 minus U1, which is like given to us as this 2 here, right? So what we need to find a fourth term, right? So we know that un is equal to a plus n minus 1d, right? So since we want to find fourth term, it means that n is 4. So this is going to give us this plus 3d. Is that right? Yes. So we know a, we know d. So let's just do substitution. So log base 2, 27 plus 3 times log of x base 2. So let's check if the result is there. No, the result is not there. So we need to do manipulations, right? So let's see what can we do. This is the same as log 27 base 2. Let us apply the third law of logarithm. This can be written as log 2x squared. No, x cubed. So bring this one up here. This one too is not there again. So let's apply another law again. If it is addition and the base are the same, we can just multiply this and this. So this can be written as log of 227 x to the power 3. Is it there? Yes, it is there, which is right here. So you see, you know it, but you should be able to also know some of the basics of some of the things so that you can do the manipulations and get your results there, right? So it's so nice. It's so nice. Let's look at 25. 25, I'll show you the shortcut, right? I'll just show you the shortcut for you to do it. So we have triangle, which is PQR with angle Q, which is 45, right? And then this is 1/2. So what will be the shortcut for us to just get R and then find this and that, right? I'll show you the shortcut. Then when I finish, I'll do the long way. So the shortcut here is, or let me do the long way first. Yes. So let me look at triangle, right? So triangle is, so let's go through the shortcut, right? Let's go through the shortcut. So with a triangle like this, well, let's assume that this is P, this is Q, and this is R. We know that when I sum up the angles, I need to get 180. So it means that P plus Q plus R is equal to 180, right? Now I know that Q, this angle here is 45. So if here is 45, then I'll have P plus 45 plus R is equal to 180. Now what is R? Because we are interested in R, right? So what will be R? 180 minus 45 minus P. So this is going to be equal to let me see. When I subtract 45 from, I'm going to get 135 minus p. Now I need to find for p, but I know that tan p is equal to 1 over half. So what is p? P is equal to tan inverse of 1 over 2. So what I'm going to do is I'm going to punch this one on the calculator, right? But when I'm doing that, I'm not going to approximate it. Don't approximate it. Write all the solutions that you are going to get. Or even if you don't want to make mistake, what you can do is you can plug it in here. 135 minus your p is now this. So I'm going to have something like tan inverse of 1 over 2, right? And then now what I can do is this is going to be equal to, yeah, so that's all. I don't want to plug it in. So now I pick 25, then I need sine of r. So sine of r will be equal to 135 minus tan inverse of 1 over 2. So I punch this in the calculator and it's going to give you something like points, right? Which is going to give you something like 0.94868 right? So having this, then what you need to do is now you point this one on the calculator and see if it's going to be like this. You change it to decimals. You check this one, you check this one, you check this one, and see the one is going to give you decimals. And you will see that when you point this one on the calculator, this is the same as what is right here. So you see the shortcut here. But if you don't do that, then you need to use the cosine rule and then sine rule for whenever you have triangle here, right? That is the idea. That's what you need to use for. That's what you need to do. I think I remember when I finish, I will see if I remember the sine rule and quotient rule, something like that. Then I'll just write it for you. Right. So the same thing for the cos. Cos r will be equal to cos of 135 minus tan inverse of 1 over 2. And this should give us something like minus 0.3162277, right? And when you figure out everything on the calculator, the one that is going to give you something like this is this, which is also C. So the idea is that this is the short way of doing it without going through any formula or something like that. Now don't forget your calculator. When you are punching the calculator, we have the radian mode and we have the degree mode. So when you are doing it, check it very carefully. Unless if you don't do that, you get it wrong. So make sure your calculator is in the degree mode so that you get the right answer here. Because when you do it in the radian mode, you might not get the right results here. Yes. So another way of doing this using the long cut is like, now I know that this is 45. So what I need to do is I can use I can also use the idea of this to get my angle. But this one, if I want to do the angle, I need to use the what is called the radian mode so that I can get the angle here. Then I used to get the angle here, and then I will use that one to work it out. So yes, the better option is just pick the angle here, put it here. So this one, when you use I think this one you can even use a radian mode to do that. Put your calculator in the radian mode, point tan inverse of 1 over 2 and see if you are going to have exact value for this. And you can plug it in and get the value here. Then you just plug it in right here and then you just get it there. Right. Okay, so 27, theta is equal to this, and we know that theta lies between 0 and 1 over 2 pi, which means that 90. So we want to find this, we want to find this one too. So let's try and go through it. So this one what will be the shortcut? Yeah, so the shortcut here is very simple. Try and check tan theta to be equal to 3 over 4. Theta will be tan inverse of 3 over 4, right? So when you get the theta, you plug it in. So 2 theta here will be equal to sine of 2 times tan inverse of 3 over 4. You point this one on the calculator, you put the results down. If we're not getting something like this, put the results down. When you finish, pick the calculator, punch them, and see the one that is going to give you the exact value here. You can do the same thing for the cos. So this one, you just change it to cos and you just do it that way. But if you want to use the long way is, now I can pick the right angle triangle where this one is 90, and I say that this is theta, right? We know that tan theta is adjacent over, no, opposite over adjacent. So what is the opposite here? So this is 3 over 4. So opposite is 3, adjacent is 4. So we need to use a Pythagoras theory to find for A. So 3 squared plus 4 squared is equal to A squared, right? And what will be this? This is going to be 25 is equal to A squared, and A will be 5. So A is equal to 5, right? So since A is 5, now we can now find for sine 2 theta. So what is sine 2 theta? Sine 2 theta is the same as sine theta plus sine theta. And what is the expansion for this? This is the same as sine theta cos theta plus cos theta sine theta. So what is sine theta? Sine theta is opposite over hypotenuse. So we are going to have 3 over 5. What is cos? Cos is adjacent over hypotenuse. So we are going to have 4 over 5 plus 4 over 5 and then 3 over 5. So when you multiply here, we are going to have 12 over 25 plus 12 over 25. And when I add, I have 24 over 25. So you see that if you use the shortcut, this is what you are going to get. And it's the same thing that we are also getting here. Is that right? Good. Then I'll do the last one. The last one is going with cos, right? So what is cos of 2? So you should be able to be knowing this one too as well, right? Because trig is something that you are going to use them throughout. Derivative too as well. So we try to know this expansion too. So this one is cos theta plus theta, and this is the same as cos theta, but this is minus sine theta, sine theta. So we know that cos theta is adjacent over hypotenuse. So we had 5 on 4. 5 on 4 minus opposite over hypotenuse, so 3 on 5. 3 on 5. I said 5 on 4, 4 on 5. So this is going to be 16 on 25, and this will be 9 on 25. Subtract, and we are going to have something like, I think 7 on 25. Yes. So do you have 7 on 25? Yeah, we have 7 on 25, which is okay. So let's check. We've gotten the 7 on 25. Use the calculator to check if we are going to get to the negative aspect. But let's check. Theta is between 0 and this, right? So when we are using theta, the question is theta in which quadrant? Because we know that in quadrants, this is positive. This is all of them. Here is only sine, which is positive, and here is only tan, which is positive, and here is only cos, which is positive. It means that here cos and tan is negative. Here sine and cos is positive, and here sine and tan is positive. So let's check where the angle is so that we can make sure that we have this one here if we are doing the thing right. So if we are doing that, let's see where the angle is going to form. So definitely we can see that the angle should be here because this 3 is positive and this is, so the angle is going to form here. So it means that here theta is actually positive. Yes. So there's no way we should have minus of this because the results should be this. but since we are having it to be minus, so those that you are using calculators to confirm, use calculator to confirm it from there. But still, we should, if it's supposed to be minus, when you do it here, we should be able to get the minus results from using this one too as well. It means that if it's supposed to be minus, this one will be greater than this, and it's supposed to be getting this. So yeah, I think this is right. So no option. Yeah, so that is the idea, because even this, all of them is supposed to be positive. Good, 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 good. Oh, let me see. Yeah, that's where it's supposed to be, because here theta is positive, so it's here. I know that it's positive also here, but the idea is that if I place the angle here, it is not going to work, because um, the x and y values are not negative values. So if they are negative values, then I can place them here and say that the answer should be negative. So that is not true. Good. So that is the idea. Let's look at 29 and 30, and it will be done with 2021, 2020, 2021. Then we start with 2022, 2021, 2022. Then we are done. Now let's look at 29. 29 here, we want to solve this. We want to find the range. So we have absolute of 2x minus 3 is equal to 9. So what can we do here? It's very simple. Let's think of this as plus or minus 2x minus 3. So let's pick the positive side. 2x minus 3 is equal to 9. 2x is equal to 9 plus 3. 2x is equal to 12. X is equal to 6, right? And we pick the negative aspect. So multiply 2 by minus 2, minus, good. Minus 2 is equal to 9, minus 3, minus this is equal to, when I subtract this, is supposed to give us 6. Divide 2 by minus 2 and you get minus 3. Yes. So what will be the solution? We need minus 3 and 6. So minus 3 and 6 is here, which is right here. Good. So that will be the solution from there. So you should be able to know some of them so that you do them very quick. So now we want to express this one as a product. I love this type of questions. I love them, right? So we have some rules and a trick that you need to know, right? So one of the trick that you need to know is, if I have sine A minus, so this is minus, so I'm using this minus aspect, sine B, then this is the same as 2 cos of A plus B divided by 2 sine of A minus B divided by 2. Yes. So this is how the product. So please go to Math 101 textbook and learn the rest. There are, I think, 4 or so. Yes. We have the one that goes with this, and this is plus. So I think this one, when this one is plus, this one will swap. When it is plus, you are going to have 2 sine A plus B over 2, and then the cos will take the minus A over 2. That will be the plus. And then we have the one that goes with cos 2 as well, right? So now what is A now? Looking at sine 3x minus sine 5x, A is equal to 3x and B is equal to 5x. So this is going to be 2 cos 3x plus 5x divided by 2 sine 3x minus 5x divided by 2, right? Good. So this is going to give us 2 cos of 8x over 2 sine of, when I subtract, I get minus 2x over 2, right? So this is going to give us 2 cos of 4x, then minus x. But what can we do here? We know that sine is an odd function, right? So sine of minus x is the same as minus sine of x. So it means that this can be written as this here. So this is going to give us minus 2 cos of 4x sine of x. So what will be the results that we have here? which is right here. The resources right here. Good. So it means that here, if you don't know this formula here, you will not be able to do this. Right. So learn the formulas and then it will help you too. So yes, we are done with the 2020, 2021. Now we are come to start with the 2021, 2022, right? So that is what we are come to start with. So now let's go through this one too and see what we can do. Right. So now this one we just need to use laws of what? Logarithm, right? So I know that log of BA is equal to C. This is the same as B is equal to AC, right? So I know this. So it means that when I compare this one, my B is root 2, my A is 2, and my C is what? X. So this is going to give us something like, what am I going to get? Yes, I'm going to have, so log root 2 base 2 is equal to X. This is the same as root 2. Let me use the black pen, and this will be 2X. Now, root 2 is the same as 1 over 2, it is equal to this. And when we are using indices, since the base are the same, the top should be the same. So X should be equal to 1/2, right? So we are going to get our answer here to be P right there. Now let's look at 2. Now X minus this is less than minus that. So you will see that this one you'll be like on hurry to just say that, okay, let me change this one to plus or minus 4 minus X, as we all know, and then you start doing. But one thing that you need to notice here is that this one, there is no solution. Even if you do it, yes, you are not going to get solution. Why? Because you see, we said absolute value here, because there is absolute value on this. Every value here will be positive. There is no way positive value is less than negative here. So here, the answer here should be empty. You see that? Because we don't have any value that is going to give us something like negative. Because absolute values cannot be less than negative values, right? So let's assume that you didn't know, you are writing it quick, right? So you just change this one to plus or minus 4 minus X less than this. Let's try and check it out. Positive side. So what do you get? Minus X. I move the 4 there. Minus 4. Minus X is less than minus 7. Divide 2 by minus 1 and the sign will change to be greater than 7. Then you pick the minus aspect. Minus 4 minus X is minus this. Multiply 2 by minus 4 plus X is less than minus 3. X is less than minus 3 plus 1, and X is less than 1. So you see that we have something like this here, right? So you see that S is greater than this and S is less than 1 here. So you will be quick to pick this one. But the idea is that for you to get this one, you cannot just say that this or this. You need to put it on the number line and see if it is going to satisfy the equation. So let's pick it out. 1 will be here and 7 will be here. Right. So what am I going to do? I'm going to pick any value here and see if it is satisfied this equation here. Right? And the same thing here. So let's pick something like minus 1. Let's plug in minus 1 here. When I plug minus 1 inside this, so let me underline this one with red, the one that we are going to use. Put minus 1 here. 4 minus minus 1 is going to give us what? 5. Is 5 less than minus 3? No. It's not going to work. Is that right? Okay. Let's pick any value here. We can pick something like 2. Right? Put 2 here and plug it in. Very close to 1 because that's where we are picking it from. So 2. When I pick 2 here, 2 minus 2 is like Oh, we are the one. Sorry, we are the one. So we are the one. So we need to use this. So when I pick -1 here, plug in -1 here. -1 when I plug in -1 here. No, what I'm doing is like I'm plugging them here rather. 4 minus x is less than -3. Yeah, that's why it's going to give us the original solutions. So because when I do this, when I do it here, it's going to satisfy, but we need to look at it satisfying the original equation here. So pick 0 or -1, plug it in. When I pick 0 here, 4 is not less than -1, -3. When I even pick -1, I'll get 5. 5 is not this, so this is not true. Pick any value here. You can pick 6, you can pick -2, you can pick 5. When you plug them here, when you pick 5 here, 4 minus 5 is -1. Absolute of -1 is 1. 1 is never less than this. So any here 2 is not going to satisfy. Pick anything here, 8 and above. Put 8 here. 4 minus 8 is -3. Absolute of 3 is 3. 3 is never less than -3. So this is also not going to work out. So you see that this is everything is not going to satisfy the equation. So this one, if you don't take care, you might choose C, which is not true. So the answer is supposed to be A. Is that right? So that is the idea with question 2. Now let's look at question 4. Now, yes, question 4 is good because this is greater than 4. So since it's absolute, it's possible that we can get values of, values of let's say x that is going to give us that, right? So now let's check that. So this is greater than 4. So definitely we can change this one to plus or minus. Pick positive with this greater than 4, and x will be greater than 4 minus 3, and x should be greater than 1, right? So this is kind of like interesting. So x should be greater than 1. Then pick negative. So minus x minus 3 is greater than 4, and this is minus x greater than 3, this plus 3 minus s is greater than 7. Divide through by -1, and the sign will change to be less than -7, right? So we can see that s should be less than -7 and x should be greater than 7. So the answer here, or the results here, should be A, right? So you see that this one we were able to do that because this is positive. So you see that, let's even confirm. Pick any value that is greater than 1 and plug it in. You can pick like 2, 3, 4. So put them here. So put 2, put this one. You can see that every value here will be greater than 4. Now, all values that are less than -7 can pick something like -8, -9, just going, and you see that it's true. Put -8 here, plus this will be -5. Absolute of 5, -5 is 5. 5 is greater than that. And you see that it worked true for us. Now, let's look at question 4. So we have this union that. So what we need to do is, first we need to define our Venn diagram, right? For P intercept Q, right? So what will be P intercept Q? Good. So we are going to have something like this. We're going to have something like this. So let's assume that this is P, this is Q, then P intercept Q is going to be here. Let's look for let me say P intercept Q prime. Now, when we write something like this, remember when we started Math 101, we said this means that this is the same as P difference Q, right? And this is like when I'm subtracting, let me say P from, like when I'm subtracting Q from P. So this is like P only, right? So it means that the Venn diagram for this is going to be something like this, something like this. So this is P, this is Q, then P only will be this. Do you see that? Good. So what's the question? Now the question is we want to find P intercept Q prime union P intercept Q. So it means that now we need to combine this graph and this graph. We need to shade them together. So let's shade this graph together. So this is going to give us, let me use blue for my Venn diagram, and then have my this one here, and have my this one also here. So let's assume that this is P, this is Q. So we know that from the first one, we have something like this. From the second one to we have something like this, because all of them, we need to shade all of them. And also we have something like this. So combining them, what you can see? We can see that we are actually shading all P, right? It's actually all P. Oops. So this is like equal to P, right? So the results here should be C, which is P, which is P, right? So that will be the results for question 4, right? So let's look at question 5. Let's look at question 5. So question 5, we have this cubic function here, and we just want to go through them, right? Now this we can just solve them, or this one, if you know it, you just choose them, right? It's very simple to do that. So what can I do? What can I do to make sure that this is going to work it for me? So I'll just go through the process, but know it, right? Know it off head, so that when you are doing it, it's just going to be simple for you, right? So what I'm doing here is, here we want to find a relationship between the sum of zeros and then the coefficient of P of X, right? Sum of zeros and coefficients of P of X. So remember that, when you're talking about the sum, it's just something simple, like we are looking at the sum of this and that, this and that. So let's just do something very nice. So I'll begin with just proving it, but know it off head, right? So that you can just know that, okay, this is how the thing's supposed to be, right? So s cubed plus x squared plus x1 x plus a naught. So this is supposed to be 0. It's supposed to be equal to 0 because we are looking at the factors, plus x1 x plus x naught is equal to 0. So what I'm going to do is, for this one to hold, I need to divide all of them by x to the power, the coefficient of s cubed. So when I do that, I'm going to get this plus, this one's supposed to be 2a2 divided by a3 x squared plus a1 a3 x plus x naught divided by a3 is equal to 0. So I'm showing you how to get it, but when we finish, you need to also learn how to use the idea of knowing the shortcut. So now you know all the formulas, so you just pick them straight away, right? So what are the roots? Now we are saying that, you see, I set this one to be 0 because they are saying that these are the zeros, right? So when you're talking about zeros, it means that when I plug them in, I should get 0. And it has a 0 of this, this, and that. So what it means is R1, R2, and R3 are zeros, right? So it means that, like, x is equal to R1, x is equal to R2, x is equal to R3. And I can form the factors here. X minus R1 is equal to 0, x minus R2 is equal to 0, x minus R3 is equal to 0. And from here, I can form the equation x minus R1, x minus R2, and then x minus R3 is equal to 0. So what am I going to do here? I'm going to expand this to make sure that this expansion is of this form. Then I'll compare the functions. So stay here and you see how we are going to form this very nicely here. So first, I'll just expand this 2 here. So let's do the expansion there. So this will be x squared. This time this will be minus x r2 minus x r1 plus r1 r2 multiplying x minus r3 is equal to 0. So what can I do now? S squared will multiply everything here. This will multiply everything here. This will multiply everything here. This will multiply everything here. So let's go through that. I'm going to have x cubed minus x squared r3. Then I'll multiply this one too. So I'm going to have minus x squared r2 minus x r2 r3. No, it's supposed to be plus because this is minus, this is minus, this is positive. Now this go through this. So I'm going to have minus x squared r1 plus x r1 r3. Then the last is this one. So I'm going to have plus x r1 r2 minus r1 r2 r3 is equal to 0. So let me shift it small. So this is equal to 0. So let's group items in a form that we can have the one with s cubed, x squared, x, and the one without x. So let's do that. I have x cubed here. Let's look for all the terms with x squared. So this is with x squared, this is with x squared, this is also with x squared. So what can we see here? We can see that we have, so when I factor x squared out, x squared out, x squared out, it's going to be left with plus, in bracket here, I'm going to have, so let me arrange them, right? So I have r1 here, r2 here, r3 here. So I'm going to have minus r1 minus r2 minus r3 with x squared, right? Then plus, now let's pick the term which is in terms of only x. So the term with only x is this, this, and this one too. So I'm going to have it, I'll arrange them with the one, so r1 r2 which is here, then I have r1 r3, then I have r2 r3, right? So plus r2 r3 which is going with the x. Then the last one is the one without constant term, which is the minus r1 r2 r3 is equal to 0. Good. So this is what we are getting now. So what I'm going to do is I'm going to clean up all the solution here that we did here and then move the final solution that we've gotten up. So now this is like we have one equation here, we have another equation here, which is also in the form of s cubed, s cubed. So what can we do? The coefficient here is 1, which is the same as this. So that's the reason why I first divide 2 by x, the coefficient of x to the power 3. So what's the coefficient of x squared here and coefficient of s squared here? It means that minus r1 minus r2 minus r3 is equal to a2 divided by a3. It means that r1 plus r2 plus r3, like when I factor minus out, will be equal to minus a2 over what? a3. Right. Then the coefficient of x here is the same as what is here. So r1 r2 plus r1 r3 plus r2 r3 is equal to a1 divided by a3. Is that right? And the last one is the coefficient here, which is without x, is equal to this. So this is minus r1 r2 r3 to be equal to a0 over a3, and this is the same as r1 r2 r3, which is equal to minus a0 divided by a3. Good. So let me just clean this one out. So see and clean this one too out. So see what you've gotten. You've gotten this one here, and this one here, and this one here. Now what is the name given to this guy here? This is sum of roots. But this sum of roots that we are talking about is sum of roots. How many roots? 3 of them. Right. So you see that the one that we did was let me say quadratic, right? So the sum of roots was just 2, alpha plus beta, or r1 plus r2, right? Now, how do we call this one? We call this one products of, no, sum of, sorry, I think sum first because it's going with sum of two products, sum of two products. And now this one is now called product of roots. So sum of two products, it means that we are summing two products, right? So that's the idea. So now let's go through the question. So the question is asking us, find a relationship between zeros and the coefficient of p. So what we need to do now, anytime we see this something like, then this is talking about the sum of products, but this one is the one that's going to with this one. So how do we get that? Now we know that the sum of root is just the coefficient of this minus coefficient of this divided by this, which we had it here. So minus a2 divided by what? a3. So which one is right? This one right here, right? So we are going to have this one to be this, because we have already even derived that, which is right here. But how do I know? This one I need to know it of it, that when I'm finding the sum of roots, it is minus this divided by that. Now, if let's assume that this is like ax cubed plus bx squared plus, let's say, cx plus d, right? Plus d, then what am I going to get? Plus d. Then this is like, the results here is like equal to minus b divided by a, like the same as the product root. But the idea, the same as the quadratic, right? Is the same as the quadratic, like b divided by this minus. Is that right? Good. So it means that this one, if this one is equal to like this one that we are having here, then this one will be c divided by a, which this one is like the product of root or under what? The quadratic. And the last one here will be, this one here will be minus d over a. So learn how to derive the whole process here. Now do we have something like 1 root plus this? No. So here, one thing that you need to do is, here is either we are talking about sum of product or product rule. So this one, since this is r standing alone and we have the product, this one is not true. This one too is not true. This is true, and this one too is true, but we need to look for the one which is true. Now this one here should be minus a naught a3. So there is no minus, because we need to take minus of this divided by this. So it means that this is not true. Then this is the sum of two products, or sum of product, which is a1 divided by a3, which is true. And that's what we derived here. So it means that the right choice for us here is to choose what? C. Right. So that will be the right choice for us to choose. Good. So now know that this is how the function is going to be. So this is also the same as minus b over a when we are dealing with cubic, right? So this, that, and that. Good. Let's look at question 7. Let's look at question 7. So what is question 7? We have this here. Minus 1 is a zero of this. Find the other factors. So since minus 1 is a zero of this, then we can say that x is equal to minus 1, right? And x will be equal to, x plus 1 will be equal to 0. So it means that this is a factor of this. So we can use the long division to form a quadratic. Then we use the quadratic to look for the other root too as well. Or I think we have a short way of doing this. Okay, so the short way of doing this is, you can plug in 1 and see if it is 0. That's a very short way. Yes. So this one, since it's section A, I pick P of 1, plug it in and see if it's going to give me 0. Right? So plug in 1. 1 cube is 1. 1 squared is 1 plus times 3 is this, minus 1 minus this. So this is 0. So you know that the first order root, which is x is equal to -1, will give us 0. Now we've gotten s is equal to 1, which is 0. So it means that this option is out. Like this option is out because we don't have 1. This option 2 is out because we don't have 1. So now what we need to do is we need to check 3 and -3, which is going to give us 0, and then that one will give us the results. So let's plug in 3. 3 cubed plus 3 times 3 squared minus 3 minus 3. What are we going to get? This is going to give us 27. This will be 9 plus 27 minus 3 minus 3. So this is not going to give us 0, of course, yes. So it means that, yes, -3 is the one that's going to give us 0. So P of -3 will be -3 cubed plus 3 minus 3 squared minus -3 plus, no, -3. -3 cubed is -27 plus -3 squared is 9. 9 times 3 is 27. Minus minus will be positive, and then this one will be minus. So this one should be 27. So this will cancel this, and this one to cancel the given as 0. So x is equal to -3. So the point that we need to use here is this. So this is another way, that this is a shortcut way of getting it. But if this is not the shortcut way, then it means that what we need to do is we need to use the long division. So as I was trying to do here, we need to use the long division, which is, now I set s to be equal to -1, x is equal to x minus x plus 1 is equal to 0. So I need to use the long division like x plus 1. Then I have this here. Then I have x cubed plus 3x squared minus x minus 3. S goes here how many times? X squared. So on the top, let me use, so x squared. Then x squared times this one is going to give us s cubed plus x squared. Subtract. This and this will be 0. This minus this is going to give us -2x squared. This divided by this is going to give us -2x. -2x times this and times this is going to give us -2x squared. Then, so here we need to add the minus this here to it. Then -2x. Subtract. This and this will be 0. Minus, minus, minus. This one will be positive. So this is going to give us x minus 3. X goes here 1. So this is going to be plus 1. So this is going to be x. Oops. I think there is a mistake somewhere that I need to check, because when I multiply, I should be able to get everything to be summing up to 0. So this and this will be 2. This will be positive. Is that right? Oh, okay, okay. Same. So this one should be positive, not negative, because when I multiply this one, this was 3 minus 1 supposed to be positive. So this one's supposed to be positive, and this one's supposed to be positive. So when I multiply, this one to be positive too as well. So this is going to be -3. So this is going to be -3. Then when I multiply, -3x minus 3. And this one is going to give us 0. So you see the one on the top here, this is already giving us. So we are just picking the one on the top, which is x squared plus 2x minus 3 is equal to 0. Then we find the factors here. So here, two numbers that when we add, we are getting 2, but when you subtract, when we add, we are getting 2, but when we multiply, we're getting 3 is x squared. So this is going to be like minus x minus 3x minus 3 is equal to 0. Because 1 times 3, no, this one should be positive. So 1 minus 1 times 3 will be -3. -1 plus 3 is going to be 2. So here I can factor x out, and I'll have x minus 1. Factor 3 out, x minus 1 is equal to 0. So what am I going to get? X plus 3, x minus 1 is equal to 0. Solve them. X minus 1 is equal to 0, x is equal to 1. X plus 3 is equal to 0, x is equal to minus 3, which is the same as what we had as D. So you see the short way. So if you don't know the short way and you know this long way, then you need to go through all this, which is like you are wasting a lot of time because you need to go through the whole process before getting it. Meanwhile, somebody that knows this has already tried to test the values here to get what is here. So that is one thing, one trick with objectives. Sometimes you can use the solutions to get what from the question. You can use the solution to get the questions, and then you are done. Now let's look at question 8. Let's look at question 8. So question 8, which of the following is true about absolute value function and its graph? So now we are saying that it is symmetric. Yes, it is symmetric. Is it symmetric? Yes. It has only positive domain. It open upwards. It has a vectors at 0, 0. So it is not true. The vectors can be 1, can be 2, right? So C is out, like basically C is out. And then it open upward. It is not true. It can also open downward. Yes, so this one too is out. It has only positive domain, which is also not true. We can have negative domain too as well. So the only one which is true here is what? The A. It's symmetric. Yes, it is symmetric. So absolute value and its graph is symmetric. You can just have it to be symmetric. Right. So now let's look at question 9. Question 9, we want to find vertical asymptote. So as I explained in 2023-2024 video, we said for vertical asymptote, we are looking for the values that will make the function undefined, right? So domain is trying to ignore them. Vertical asymptote is saying that I need them. So for vertical asymptote, if the function is a fraction like this, we just pick the denominator and set it to 0. So x squared minus 1 is equal to 0. This is difference of 2 squares, so this is x minus 1, x plus 1, which is equal to 0. So x minus 1 is 0, x is equal to 1, x plus 1 is equal to 0, x is equal to minus 1. So what will be the domain? Domain. So here, let's go and check. Now, okay, so there was a trick here. So we have x plus 1. Do you have x plus 1? Yes, we have x plus 1. Do you have x is equal to 0? No. Do we have 2x plus 1? No, we don't have this one too. So the option here should be A. So he just gave us one of the options, like this one right here, without finding the x values. What is the horizontal asymptote? So I said horizontal asymptote and oblique asymptote. Actually, if we have horizontal asymptote, then there is no oblique asymptote. So what is this? Now, for us to check the horizontal asymptote, what we need to do is we need to check the degree of the top and the degree of the down. So the degree of the top is 1, the degree of the down is 2. So we can see that the degree of the down is less than the degree of the down. So it means that here the horizontal asymptote is y is equal to 0, right? Because when I find limit as x is approaching infinity, we see that this one is going to give us 0. Now, what is y is equal to 0? I'll just show you that if I have x axis and I have my y axis, and I ask you to draw y is equal to 0, why are you going to draw it? So you will see that y is equal to 0 is, you are going to draw it here. Y is equal to 0. And this is what we call the x-axis. So instead of them giving us y is equal to 0, they are saying that x-axis, which is true. So this is the x-axis, which is y is equal to 0. Now let's look at question 11. So question 11, we want to look at a translation from this graph, right? So we have f of x, which is equal to absolute of x. So let's look at the translation. So we are saying that this graph here moves 4 we need to the left. 4 we need to the left. So 4 we need to the left means that x is equal to -4, because if I have this graph here is like this. So if I move 4 we need to the left, then I have -1, -2, -3, -4. So you will see how I'm going to translate this graph here. So this graph is moving to the left. 4 units from the left. 2 -3 -4. So I'm going to move like this to the left. It means that s is equal to -4. So how do I make sure that I fix this one in here? So it means that here x is equal to 0. So now I'm going to fix x plus 4 inside this. So my new f of x is going to be absolute x plus 4. Now let's continue to the left, and 7 we need down. So 7 we need down means that we need to go down on the y-axis. We are going down. Down means that we are going to the y-axis. So I need to move 7 we need down. So it means that the graph is going to be like this. This is -4. 7 we need down means that I will be at -7, and the graph will be something like this. So 7 we need down means that y is equal to -7, right? So I need to subtract 7 here, because remember this is y, and y is equal to -7 means that I need to have y is equal to -7 here, so that when x is -4, this one will be 0, and I have my y is equal to -7 here. Is that right? Good. So it means that what will be the option here? The option here should be C. Yes, it should be C right here. Good. So this is how you can analyze section A, and then you just get your answers done. And let's look at question 12. What happens to the graph of gen of x, if we have something like this? If a changes from 2 to 1. So now we are looking at the idea that gen of x is equal to absolute of x a. Now if a is 2, now it's changing to when a is 1. So we are going to have something like this. So now let's draw the graph for this. So you see this one, because this is 2, is going to widen the graph, right? Like let's assume that we have gen of x. Let's assume that we have gen of x to be equal to absolute of x. Then what will be the graph? The graph here will be this, because here when x is 1, y2 will be 1, right? When x is 2, y2 will be 2, in that order, right? But here when this is equal to 2, what happens? It's going to make it wider, because now here when x is 1, what happens? Y will be 2, right? So it means that the graph is going to be something like this. The graph for this one, the graph for this here is going to be like this. When this one is 1, instead of it to be 1 here, it's going to be 2. So it means that it's going to be here. So instead of this one to be here, so I'm just trying to picture all the two graphs in the same this one for you. Let's look at when x is 2. When x is 2, this graph here will be 2 here, but when it's 2 is going to be at 4. So I'm going to have something like this. Let me just clean this one. 2 and 4 will be somewhere here. So even let me just picture this graph here for you to see. So you see that this graph is here. This is when gen of x is equal to absolute of x, right? That is when x is 1, y will be 1. X is 2, y will be 2. Then let's look at the other graph. This graph here is when this. So what can you see? So you can see that the graph, this one, the graph here, this is gen of x is equal to 2 absolute of x. So it means that when we are moving from this to this, the graph becomes wider. Is that right? The graph become wider because when I'm moving from, because that's what the question, we are changing from 2 to 1. So the graph become wider because this one is like narrow, right? And when I'm just changing the 2, the graph becomes like it's open, it's like this. So this one is going to be like, this one too is going to go like this, and this one is going to go like this. So this one becomes wider. So this is what we are going to get here. So we are going to have CY here. It's going to be wider. The graph becomes wider and wider. Good. So I think we need to change. We need to do some changes in our results. I think in the book we did it D. It is not going to narrow it. It's going to bring it, going to make it big like that. Right. Now let's look at question 13. Which of the following is true regarding the graph of the function f of x is equal to this? So the graph opens downward. So the best way to do this is we need to do the graph, right? We need to just do the graph. So when you do the graph, it actually helps you to check it up. So f of x is equal to minus x plus 1 plus 5. Here, let's do something like when this one is, we are going up 5 with it because it's positive, because when x is minus 1, this will be 0 and y should be 5. So we are going to get 5 here. Then what happens when y is 0? So let's check when y is 0. So this is when we get the 5 when x is minus 1. Oh, good. So even we cannot just say that it's that. So this one, when x is minus 1, well, let me just do it. Let me make this one to be 1, x plus 1 plus 5. So when y is 0, this will be minus x plus 1 plus 5. So move it here, x plus 1 is equal to 5. Let's check it plus or minus, right? So plus or minus x plus 1 is equal to 5. In the positive aspect, x plus 1 is equal to 5 and x should be 4, right? And then in the negative aspect, we are going to have minus x plus 1 is equal to 5. X plus 1 is equal to, I divide through by minus and I get here to be minus, and x is going to be minus 6. So I'm going to have a point where I have 4 and 0, and then I have point minus 6 and 0. Now let's look at the aspect where x is 0. So when x is 0, I'm going to have y to be equal to absolute of minus, when x is 0, I'm going to get 0 plus 1 plus 5. So this will be y minus, this will be minus 1. Don't forget the minus is out. So absolute of 1 will be 1 and the minus plus 5, and y will be 4. So I'm going to have 0 and 4. So let me try and plot this, right? So 0 and 4 is somewhere here. 4 and 0 will be somewhere here, right? And then 0 and 6 will also be somewhere here. So this is how I'm going to get the graph. So the graph, this is how the graph is going to be. So this is minus 6 and this is 4. So it means that the graph should open downwards. The graph is going to open downward. It's going to open downward like this. So this is how I get the graph. But you know, one thing that without even drawing the graph, the way I can see that this graph is going to open downward is this minus here. How did I see that? We know that the function, a graph is at its maximum when it has what? A negative here. So we see that maximum, concave down. So this minus alone should tell me that this is going to open downward. So the solution here is that. Right. Good. So that is the idea with question 13. Let's look at 14 and 15. So yeah, quick, we can just pick it straight away. plus or minus 2x minus 3 is equal to 4 minus x, right? So let's consider negative, let's consider positive, right? And then we are done. So let me consider positive. What am I going to get? Plus, so positive will be 2x minus 3 is equal to, so what am I going to get? Move the x to the left, 2x plus x, move 3 to the right, so 3x is equal to 7, and then x will be equal to 7 over 3. Let's consider the negative. 2x minus 3 is equal to minus 4 minus x, multiply 2 by minus, move minus x to the left, 2x minus plus x is equal to 4 minus this. So this will be minus x is equal to 1 and x is equal to minus 1. So we have s is equal to this and that. So what's the question? Find one solution to the equation here. Okay, so we have one solution, which is s is equal to minus 1. So this one will be b. And then also the other solution. So other solution is 3 over 7 over 3, which is also here. Right. So we splitted them to this. So this one, this kind of questions, I love them because the idea is that I do this one, then I'll be able to get two of them out of that 3. Now, what is the total number of terms in this expansion? Okay, nice. So a plus b, 3, 17. So what I need to do is I need to multiply this one by this. So what is 17 times 3? 21, which is 1, 51. So this is going to be a plus b, 51. But the idea is that we cannot expand this. So don't go and choose that this is 51. So we are going to get 51 expansion. But the only assumption I can give it to is, let's assume that this is a plus b squared. Let's expand this and see what we are going to get. A plus b, a plus b. When you expand, what do you get? A squared plus ab plus ab plus b squared. And what will be the terms? A squared plus 2ab plus this. So what did we see? We saw that with x squared, how many terms did we have? 1, 2, 3. It means that when this one is 3, we are going to have 4 terms. When it is 4, 5. So it means that when this one is 51, we are going to have 52 terms. So this is what we are going to get from there. So this is going to give us 52. So multiply the top and add plus 1 to it. So anytime you want to know the terms in a function, just add 1 to it, and then just add 1 to the what's on the top here, and you are going to get it to be the number of terms that we are going to get. Good. So this is going to be A right there. Right. So I think mistakenly in the book we chose B. It's supposed to be A. Right. Good. So let's look at I'll just do all the corrections. Let's look at 17. 17, this is like partial fraction. Right. So this supposed to be y because the function is in terms of y. So what can we do? Let's go through the partial fraction. So f of y is equal to this. So let me write 2 over 4 minus y squared. This is difference of 2 squared. So I can write this one as 2 minus y, right? 2 plus y. And we are saying that this should be the same as m gen of y plus n h of y. So what I can do here is I can say that this is m divided by my gen of y. I will choose this. So 2 minus y plus this is going to be 2 plus y. Good. So now let's go to the partial fraction here. So what will be the LCM here? This and 2 plus y. So what can I do? This one will cancel this, it will be left with this. So I'm going to have m 2 plus y plus n. This will cancel this, we're left with this. So n 2 minus y. Since the denominator are the same, we equate the what? The numerator. So we are going to have 2 is equal to m 2 plus y n 2 minus y. Let's use the cover up method. When y is equal to 2, so I'm going to have 2 is equal to m, here will be 4. 2 plus 2 is 4. This one will go to 0. So my m will be equal to 1 over 2. When y is equal to minus 2, I'll get 2 is equal to, put minus 2 here, this one goes to 0, and I'm going to have n, and I get minus 4 here. And my n will be equal to minus 1 over 2. Good. So m is 1 over 2, and my n is also 1 over 2. So definitely it means that I'm not going to get a result for that. Or let me see. Oops. I think what did I see? Okay, so 2 minus minus 2 will be 4. So this one should be positive. Oops. Good. So this one too should be 2. Yeah. So n2 will be 2. Good. So that is right. That's right. Good. Right. So that is 17 and 18 going to the partial fraction form. Right. Now let's look at 19. What is the degree of a polynomial? What's the degree of a polynomial? So the largest coefficient of x, lowest the power of x, smallest coefficient of x, highest power of x. So yes, so for us to get the degree of the polynomial, we don't need the coefficient, right? They are not the coefficient. The degree is x to the power, to the highest power, right? So the highest power of, let's say, a quadratic form is 2. So here, the answer here is supposed to be D. So that we know that, okay, this is the highest, thing that we are getting. So it's supposed to be D. All right, so let's look at this question here, which is, we have question 20. We have M, N, O, and then N intercept O consists of 8 elements. So this means that the number of elements is 8. And then set N intercept consists of 7 elements. So number of M intercept N is equal to 7. And then O intercept M is also equal to 7. Good. So the question is, we'll find the minimum element in M union N union O. So this is going to be very simple. This is going to be, let me see. So we have this, we have that, and we have this. Good. So what we need to do is, this is equal to, let me just check it here. Let me just use a Venn diagram to check it out. Okay. So I have something like this. I have something like this. I have something like that. So let's use a Venn diagram to find the minimum value here. So I have, let's say this is M, this is my N, and this is my O. Now remember, this here is a value that is common to all of them, right? So since I have 8 here, I have 8 here, and since I have 8 here, I have this one here, I have this one here. I can place 8 in the middle. So when I place 8 in the middle, The question is, what is this shape here? Now remember, this shape is n intercept O. What is n intercept O? N intercept O is 8, right? It's 8. So it means that no, this one's supposed to be 7, because the thing what is common to all of them here is 7, 7, and we have 7 here. So that when I pick N and O, I'm going to have this one to be 8. So it means that here should be 1. So that 7 plus 1 will give us the whole of N intercept O. Now what is O intercept M? M and O is kind of here, right? But they are 7. So since we have 7 here already, then what should be here? Here should be 0. Do you get it? Yes. Then what is NM? NM is here, but that one too is equal to 7. So we need to have this one to be 0. So that 0 plus this will be 7, 0 plus this will be 7, and this plus this will be equal to 7. So now our function here is going to be 0 plus 0 plus 1 plus 7. So 0, this will be the minimum, which is going to be 8, which is right here. That will be the minimum value that we are going to get. Good. Okay, so now let's look at question 21. We are almost done. We have like 9 questions and then we are done. Question 21, let's see. Which of the following statements regarding set is false? So we know that P intercept P is actually true. Yes, without even using anything. Let's look at B. P union P is actually also P, which is true, because all elements in P can be found in P. Let's look at D before we even talk about C, right? Okay, let's see, let's talk about C first. So this, now remember how we said this, right? So we said that this can be written in different forms. So this one can be written as P intercept Q union R or prime. Do you remember something like this? Yes, you do remember, right? So we can have something like this. But is this true that this is the same as, is it the same as what we have here? So we can, for us to do this, we can just use the proof to see if it is true, right? But before we talk about the C, let's look at D. It's a De Morgan's law. Let's see. We said that U, Q, or prime here, this should be the same as P prime, but not the same as union, but changes to what? Intercept. So it means that D will be the one what is false. It means that this one here is the same as this, and it is true. When you prove that, if we are doing the proof, you can see that this is the same as this. Let's look at 22. 22. What is this equivalent to? So we just did it. So M difference N is equal to M intercept N complement. So this one should give us C. 23. We have X is equal to 16 and 2x is equal to 6, right? And we want to find the true set. We want to check for the set, right? We want to look at what is happening with the set. Now what you need to know is when you see end means that intersection. So we want to look if this values intercept this. We want to look at if we have any value which is common to this. So let's find for x here. Oh, this is squared. So x squared, when I want to find x will be equal to plus or minus 4. Intercept. When I find x here, I'm going to have x is equal to 3. Do you have any element which is the same as this? So let me write, this is going to be minus 4 and 4. Intercept 3. So this should be empty. So the best option for us is B. Is that right? Good. So now let's look at 24. 24. Good. So we want to find A difference B, and we said this is the same as A intercept B complement. Is that right? So we have A here, we have also B here. And remember, they are all natural numbers. So it means that our universal set is natural number, right? That will be our universal set. So now let's find for A. A is when x is equal to 2 to the power n. But we are saying that the n should be less than 6. What are natural numbers? So let's try and put 1, 2, 3 up to positive infinity. So since n is less than 6, then it means that n is 1, 2, 3, 4, 5, 6. Less than or equal to 6. So what will be x? X will be when I plug in 1, when I plug in 2, when I plug in 3 up to 6. So x will be 2, 4, 8. 8 times 2 will be 16. 16 times 2 will be 32. 32 times 2 will be 64. And then 64 times 2 will be 128. Right. So this is what I'm going to get for the 2. So let me see. 1, 2, 3, 4, 5, 6. Okay. So this one is not supposed to be part. So it means that my A will be equal to 2, 4, 6, 16, 32, 64. So what did I do? Plug in 1, plug in 2, plug in 3 in that order, and you get your A. Let's look at B. B implies that x should be equal to 4 to the power n, and n should be less than or equal to 2. So it means that n should be 1 and 2. Right. So what will be x? When I plug in 1, I'll have 4, and when I plug in, I'll get 16. So my B will be equal to my B will be equal to 4 and 16. So what is B intercept B complement? So first, let's find B complement. So when you say B complement are all elements in the universal set. So let me bring my universal set here. That is the natural values or numbers that are not in B. So what are we going to get? We are going to have 1, 2, 3, 4 is here. So we are not going to pick 4. Then we are going to have something like 6 up to 15. Then we don't need 16 because 16 is there. Pick 17, 18, and it's just going. So what we need now is we need A intercept B prime. So what is A? This is A, right? And what is B prime? This is B prime. Or what you need to know is every element here is going to be in B prime except those in B. So we can see that 4 is here. So it is going to be out. And we can see that 16 is also here. It's going to be out. So it means that our A intercept B prime is going to be, we have 2 here, 2 is also here, right? We don't have 4 here, right? Because 3, 5, because the 4 is here. We have 8 here because in between this dot, we have 8 there. So we are going to have 8. We don't have 16 because in between here, we don't have 16 is here. So from here going, we have the 32 and then the 64. So 8, 2, 8, 32, and 64. 2, 8, 32, and 64. So the answer here was going to give us D. It's very nice. So that is way of doing that. 25. The fourth term of GP. So when you say fourth term, it means that U of 4 is equal to 8. But remember, what is UN first? UN is ARN minus 1 because it is GP. So it means that when I plug 4 in, I'm going to have A to the power 3, right? So it means that u for which is equal to 8, it means that a r to the power 3 is equal to also 8, right? And then u10 is equal to 27. So what will u10? U10 will be a r to the power 9. So a r to the power 9 is also equal to 27. So the question is, we need to find the sixth term. So the sixth term will be equal to a r to the power 5. But we need a and we need what? R. So let's do that. So this is equation 1. This is equation 2. Let's divide equation 2 by equation 1. AR9 divided by AR cube is equal to 27 over 8. Mostly we like dividing when we are using if I say when we are using geometric, right? Because the idea is that we can cancel a and then find for r. So this one will be r to the power 6 is equal to 27 over 8. And then we can have our r to be equal to 27 over 8 to the power 1 over 6. Then we plug this one in any of them to find for. So let's put this one into equation 1. So you're going to have a, then what is r? R is here. So we are going to have 27 divided by 8 to the power 1 over 6. Don't forget r is to the power 3, and this one should be equal to 8. Is that right? Yeah, this one is supposed to be equal to 8. So what can I get? This is the same as, I can cancel this and this, so I'm going to have 27 over 8, and this is going to be 3 go to SF1 and go here 2. So I'm going to have this. Then when I want to find a will be equal to 8 divided by 27 over 8 to the power 1 over 2. Right. So this is my a, this is my r. So u6, which is equal to a r to the power 5, I'm going to have, what is a? A is 8 over 27 over 8 all to the power half, right? And then times r, which is 27 over 8 to the power 1 over 6 all times 5. So this is going to be 8, 27 over 8 to the power minus 1 over 2, then 27 over 8. When I multiply this one, I'm going to have something like 5 over 6. I can use indices to add this one, but I can also point it on the calculator straight away and get my results. So when I do that, this one should be approximately 12. Right, so let's see if we have 12 there, and then this is going to give us a. So you can point to this one on the calculator, or you can use indices to add this and this. Yeah, so this will be 6 and this one will be 3. So the top, when I'm doing the top, I'm going to have like 1 over 3. So this one will be like, when I do this one will be 8, 27 over 8, 1 over 3. Yeah, so if what is this one, what is root of cubic root of 27? Okay, so I think I can simplify that. So this is going to be cubic root of 27 divided by cubic root of 8. For me, I know that cubic root of 8 is 2, so I'm going to have 8 times divided by 2. But what is cubic root of 27? 27 is the same as 3 to the power 3, so that one too is going to be 3. Good. So from here, 2 divided 8, I think 4 times 3, and it's going to be 12. Yeah, so basically that's how it's going to be. But when you're using calculator, it's fine for you to just go through that way. You know what that? 26. 26. So let's look at 26. If the numbers n minus 1, n minus 3, 4n minus this are in arithmetic progression, find the value of n. So what we need to know is we need to know that un is equal to a plus n minus 1 and d. And we are in the arithmetic progression, right? So the first term is a, which is n minus 3. Is that right? So that will be the first term. That will be the first term. Then what will be the common difference? The common difference is any of the term, like either this minus this or this minus this. It's this minus this or this minus this, and it should give us the same thing. So 4n minus 2 minus n minus 3. So 4n minus 2 minus n plus 3, and this is going to give us 3n plus 1. You can also do this minus this, and you are going to get something like something that should be the same as what we are looking for, right? So now that we know A, we know our D, we can play around it. But the way of getting this is, if we plug in this A here and this D here, it's very difficult for us to get n. So what will be the best way to do this? Now we know that with arithmetic progression, our common difference should be the same. Is that right? Yes. So it means that this minus this should be the same as this minus this. So let's find another common difference here. 5n plus 1 minus 4n minus 2. So this is 5n plus 1 minus 4n plus 2. And this is going to give us n plus 3. So with arithmetic progression, our common difference should be the same. So this and this should be the same. So we can say that 3n plus 1 should be the same as n plus 3. And we find for n. So 3n minus n is equal to 3 minus 1. 2n is equal to 2. And our n should be equal to 1. So when n is 1 and we plug them in, we see that we are going to get it to be the same thing. So let's see, when n is 1, what do we get? When n is 1 here, this is going to be minus 2. When n is 1, this is going to be 2. And when n is 1, this is going to be, is it 6? Yes, 6. So let's check. This is the first term. 2 minus 2 will be 4. 6 minus 2 will be 4. So it's that the common difference is the same thing when n is 1. So this is the best way of doing it. Let's look at 27. 27. 27. So find the sum of this, and then in terms of AP, right? So let's look at what we can do. So if you want to find a sum, this plus Q plus this is equal to, I can factor this and this out. So I'm going to have something like P plus Q plus P minus Q. Q out, and then we are going to have 2P term. Yeah, so this should give us something like P. We are almost done. Find a sum to nth terms of arithmetic progression. And then we have the nth term is n plus 1. So this one, they've provided us with the nth term, right? So when they give you the nth term, it means that un is equal to 5n plus 1. So this will help us to know, like A, we can also use to find our D, because this is arithmetic progression. So what is, when n is 1, we are going to get 5 times 1, which is equal to 5 plus 1, which is equal to 6. We can pick u2, 5 times 2 plus 1, what is equal to 10 plus 1, what is equal to 11. Then since we have u2 and u1, we can find common difference. So u2 minus u1 is going to be 11 minus 6, and this is going to give us 5. So now that we know the first term, so don't forget u1 is a. We can find the sum because the question is asking us to find the sum. So what's the formula for finding the sum? So math 101 is like a lot of formulas. So this is the formula for finding the sum of arithmetic progression. So now we know um, we know A, we know D. So what will be the sum? N divided by, what is A? A is 6. So 2 times 6 is going to give us 12, but let me write plus N minus D is 5. Now let's simplify and see what we are going to get here. This will be N over 2, 12 plus 5N minus 5. And this should be giving us 12 minus 5 is like 7 plus 5N. So let's see if it is there. 7 plus 5, and then we have it there. Okay, so we have it here, which is right here. Good. So solve more questions. It helps you to know how questions are being approached and then the right way to be getting them. Is that right? Good, 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 good. So that is what you can do from here. Good. So now let's look at 29. We are almost done. 29, this is GP. And what is the product of the first 5 terms? This is a nice question. This is a nice question, right? So first, what is GP? UN, let me use black. We know that UN under GP is this, right? So they've given us the third term, which is equal to this, which will be squared. So we are saying that this is equal to 3. So AR squared is equal to 3. But the question is, we want to look at the first 5 terms. So what will be the first 5 terms? Let's go with them. U1 is AR1 minus 1, which is A. U2 is AR2 minus 1, which is equal to AR. U2 is AR3 minus 1, which is AR squared. U4, this one should be U3. AR to the power 4 minus 1, which is AR3, right? And then U5 is equal to A5 minus 1, which is AR4. So what we want to do is, since the question is talking about the product of the first 5 terms, then we need to multiply the whole of this. So the product of the first 5 terms will be U1 times U2 times U3 times U4 times U5, which is the same as AR A times AR times AR squared times AR cubed times AR to the power 4. But do you know the smart move that we are going to do? We know that anytime we have A and R squared, it is equal to 3 from the question, because the question is saying that this is equal to this. So it means that we need to express everything here as AR squared, right? So we can shift some of the functions. So this can be written as A times AR times AR squared times, this one can be written as AR squared times R times, this one here can also be written as AR squared times R squared. So what I'm going to do is I'm going to move this R squared with this and this R to multiply this, so that R times R will be what? R squared. So it means I'm going to have R squared, which this one is multiplying this here. And then this one will multiply R, which is going to give us R squared. So times another R squared. So it will be left with this is giving us this. So let me just use red to show you. This and this is giving us this. right? And then this r here, and this is giving us this. So what is left? It's left with times r squared times r squared times r squared. So it's left with this, which is here, this, which is here, this, which is also here. So now we know that a r squared is 3. So we are going to have 3 times 3 times 3 times 3 times 3. Good. So what is 3 times 3 times 3 times 3? This is 243. So 243 is going to give us C. Good. So let's do the last question and then we are done. And I think you'll be ready for your exam too as well. So which of the following give the general solution of sine x is equal to 0.5447 for n is equal to 0, 1, 2. So, we know the idea of the sine, but what we can do is with the general solution, it's just very simple. What you need to know is you need to know the general solution, right? So what is the idea? For we know that x is equal to sine x is equal to 0.55447. So what will be x? X is sine inverse of 0.5447. So remember the general solution. The general solution is s is equal to 180n plus minus 1 to the power n sine inverse of what we had here. So sine inverse of what we had here, 0.5447. So now what is sine inverse of this? So sine inverse of this is just approximately 3. So we are going to have 180 plus, this is approximately 3. So we are going to have 3 and then minus this. So this is going to give us the C, which is right here. Good. So this is the end of this video. And as I said, make sure you practice more, go through the tricks, write down the formulas, right? Go to sequence and series, know the formulas, binomial expansion, know your vertical asymptote, horizontal asymptote, know how to find the absolute values, reflections, logarithm, properties of logarithms, like know them so that when you are doing the OBJ or the objectives, you know that this is what I'm doing. But the best way to also go through the MERB series, and if you don't have one, just go and look for one from the TS office from our manager Eric, and then you'll be able to go through a lot of questions, and then all the best. See you in the next video.